Hello, this is MicroJ11, and in this video I'm going to be showing you how this box works that I got in another video. This is a manipulator control unit. It is probably would have had some sort of an arm or it would have controlled some sort of an arm or a crane, something like that, that would have been in an area that like a clean room or something like that, where humans wouldn't be able to move the things around. So you'd use this, you'd be on one side of a wall looking through a window or something like that, and you'd have this control box here in your hand, and you'd be able to move stuff around and inside that box. So this is actually the control box for it. It would control DC motors, 5 axes, well, not exactly axes, but so we have an up and down, rotate, a tilt, X and Z. So those are our controls, and these are fuses, and then the control panel actually plugs in right there, and that plug there goes to the manipulator. And so you have to have a cord that goes between these two, but I don't have that, so I just cut this off, and it happens to fit on there, luckily. So let me plug that in here. Now these are actually only switches. So you've actually got, these joysticks are just switches. So actually when I put it one way, that you can see there, that moves for the one switch, and that's the green side. And then when I move it the other way, in that same axis, it pulls that down. Well, you can't see that, but it pulls the other switch down, the bottom part of it. And so it basically, when you move it in one direction, so if I move it this way, it will actually contact these two wires here together, and if I move it in the opposite direction, it contacts these top two wires together. That's how it works. So now this yellow, or this green, sorry, is for one axis, and that would go to these, which is the green one here. Wait, the green one actually doesn't stay the same color, I don't think. Oh, this is the green one here. So this is the green block here, and that would control one motor. So let me plug this in here and show you how it works. And we've actually also got these potentiometers on here for speed control. So you can control how fast your motor actually moves. So let me switch it on here. And got a couple of motors hooked up and a light bulb there. Oh, that's the light bulb. Alright, so we've got this motor working right now. Let me get... Alright, so that's that light. Okay, so now that motor right there is rotating. Wait, let me speed it up here. There we go, okay. So as you can see, when I put it in one direction, the motor spins one way, and if I switch it over to the other direction, it goes the other way. And you've got speed control. And you can make it go pretty fast. Yeah, the motor's not happy. So, the way these work, it's actually really simple. So each block, it has, let me get this one I took out here. This is the 5th one here. So, these blocks, by the way, this one here is made in February 1989. This one's actually 1988. But, anyway, so on the top here, it's actually not got a lot to it. It's got a couple of potentiometers to adjust the maximum and minimum speed, things like that. A little relay here, transformer for the control. It's actually got a shunt resistor here. That's probably to determine how much current is going out to the load. A bunch of resistors, a couple of diodes, things like that. But this is actually our main component here on here. This is an LM324N. This is a quad operational amplifier. So that's our main component there. And then underneath of this circuit board, we have 2 relays, a large resistor, another resistor here, another relay there. That is what is that? that's a, oh, let me think about it. This is a, this is an SCR, which is Silicon Control Rectifier. They call it a power cube on here. This thing can handle 25 amps. It's basically diodes. A silicon control rectifier is basically a diode that can be switched on and off. So it's actually got a couple of diodes in there. I'll explain that in a little bit more. I have a schematic of it. So that's actually what controls the speed, amazingly. And with only this little circuitry on here. And I'll tell you how that does that in a minute. And these two relays, one of them or both of them in combination do the direction of the motor. So that clicking sound you hear is the direction. And then the other one, probably when you shut the motor off, it shorts the motor to one of these resistors to make the motor stop spinning faster. And that is a Opto Isolator. That's basically just got a little LED in it and a phototransistor, and it basically just isolates part of the circuit so that so you can have one part at a raised voltage like 120 volts opposed to the other side, which is our control side. So so that is the bare bones of the circuit, and it's all mounted on a really thick piece of aluminum. This is very well built, and definitely well built because it lasted so long. So how this works is, let me get my diagram here. So the SCR is Silicon Control Rectifier, and it can handle 25 amps at 140 volts. That's what mine is rated at, and the gate is 60 milliamps. So here's actually the circuit of it. It's basically in the bridge rectifier configuration. So you've got your AC that comes in here, and oh, wait a minute, is that right? Yeah, that's right. Okay, so you've got your AC that comes in here, and the line, basically the positive of the sine wave gets rectified and goes through this diode through the plus side, and the other one, the negative of this waveform, would go to the negative side, and it gets cut up like that. Same over here. But these two silicon control rectifiers here will actually make it so that if those don't have a signal, then there's still negative voltage here, but because the motor's connected across these, it's not going to turn on. But if you turn those on, then you're going to get power you'll get your positive voltage, and you'll have a complete circuit, and your motor will run. So now I'm going to show you how it actually, I've got my oscilloscope hooked up here, hooked up to a light. So that's our light there, and I can control the brightness of that. And my oscilloscope's not working right now. Let me just get that adjusted here. Alright, there we go. Alright, so there's our oscilloscope. Okay, so that's full power right there. And that is what the signal coming out of a bridge rectifier diode looks like. It's got just the bumps, so it rectifies all of the positive voltage onto and sticks it all together. So now, this silicon rectifier, basically just using those operational amplifiers, you can make a very simple circuit. I'm not sure exactly how you do it, but you can look it up. It basically compares, or it basically waits until there's a certain amount of voltage, and then it shuts off. Or you can make it maybe the opposite way. I forget exactly how it works, but maybe it waits till there's too much voltage or something, and it shuts off or turns on. So what it does is, alright, so we've got 0 duty cycle right there, but as we turn up that potentiometer, it actually, as the signal increases, it cuts off part of the waveform. So the more of that sine wave you have, the brighter your light is going to be, or the faster your motor goes. So as you can see, when I turn that down, now I've only got part of that wave that's actually showing up. Let me turn the brightness up on this oscilloscope. There you go. So see how that works? That's pretty cool. So that's just those diodes, those the SCRs turning on and off. This is just my little oscilloscope. It's not even actually plugged in. I have it I'm actually connecting it up not a very smart way, but it was the only way I could do it, because it only has 2 channels and each one does not have a positive and negative terminal, so you have to connect the ground up to your power actually. So this scope is actually, if I touch ground, I'm going to get electrocuted probably. So, but that's actually, it runs on battery, so it's not plugged in even. But it's a nice little scope. So, but anyway, so as you can see there, it's a very nice waveform there. So it doesn't even need a timer or anything like that for pulse width modulation. It can use that AC 60 Hz waveform to... So the negative side is never actually switched off. It's always on. But the positive side is actually what gets your... It cuts part of the waveform off, so you get less time that the motor is actually getting full voltage. So, I don't know, I just thought it was kind of cool how it works. So I'm not sure if I'm going to keep these or not. If any of you guys have any cool projects maybe I could use these for, or any ideas. Because I'm actually thinking about selling them on eBay, or trying to. Because I looked it up on eBay, and these units, just one unit like this, a refurbished unit, goes for, somebody's asking $300 on eBay. Which is ridiculous. I mean, this is not that much to it anyway. But I guess if you have an old unit like this and you need to repair it, your company may be willing to pay $300 for one of these. But that's just their asking price. They probably wouldn't get that much. But still, that's ridiculous. So I mean, if I get even $50 for this, I mean, really the main component that I want is this right here, which it only can handle 25 amps, which isn't that much. I could buy a couple Mosfets that would, for a couple dollars, that would do the equivalent of this. So I don't know. Tell me what you guys think on that. So they are pretty cool units. Maybe I'll just keep like 1 or 2 of them. So, but yeah, I can control these different motors here, or light bulb. So you've got that motor there, different directions. Then you've got that motor. You've got your light. So yeah, that is how it works. Actually, this is another piece of it. I'm not exactly sure how it connects up to it, but it's the emergency stop and stuff like that. So that is a manipulator control unit. Hope you guys enjoyed this video. Thanks for watching.